Hey guys, it's Miss Ramon. I'm going to be doing your science mini lesson videos while we are doing our remote learning. So to start with, I want to go ahead and review some of what we did right before we were out of school. Okay, so if you look on your Monday, March 30th paper, you're going to see some of your essential questions that we did right before you guys left school. Go ahead and fill those in a second time because a little review never hurt anyone. So we're going to do the first question, what are air masses? And if you remember, air masses are large bodies of air with the same temperature, humidity, and pressure throughout. Okay, so what that means is that this body of air here might be warm and it might be 80% humidity, there's a lot of moisture in it, and it's going to bring a low pressure system. Okay, any type of air mass is going to have the same temperature, humidity, and pressure throughout. What happens when we have two different air masses that meet? You have a mass of cold air that meets up with a mass of warm air. Anytime two air masses meet, a front is formed. Any type of front, doesn't matter what kind, is going to bring rain or snow. All fronts are going to bring some type of precipitation. So make sure that you get this down on your paper. You can pause the video and do what you need to get this down, but all fronts bring rain or precipitation, okay? Next, we're going to be moving into how do air and ocean currents affect global weather. So we're going to watch a quick video on what that looks like as far as convection currents and how they affect the weather around us.
This movement creates surface winds. Wind is the horizontal movement of air over Earth's surface. It is one of the basic elements of weather. The movement of air has more global effects too. The rising warm air, along with the sinking cool air, creates what is known as convection currents. Convection currents can bring turbulent weather as well as soft sea or land breezes. Temperature, air pressure, and movement of air by convection currents are closely related. They work together to circulate heat throughout the troposphere and produce many of Earth's varied weather patterns.
Okay, so we're going to watch that video again. And I don't know, in my classroom we always watch our videos twice. We watch them one time through and then we go through again and we pause and we take notes. So go ahead and take out your second set of notes for today. It looks like this. Okay. And we're going to be switching back and forth between the video and our notes.
Air moves from areas of high pressure to those of low pressure. This movement creates surface winds.
Okay, so that's our first piece of information that we need. Wind is created when there's an area of high pressure that is chasing an area of low pressure. So I'm going to put meet or chase areas of low pressure. So a picture that's going to go with that is going to show us that wind will always flow from high to low, okay? Anytime you have a high pressure system and a low pressure system, that high pressure system doesn't like the pressure that it's under and it wants to balance itself out. So it's going to chase that low pressure trying to find that balance of pressure. So we're going to put our area of high pressure and our area of low pressure. And the area of high pressure is trying to get towards the area of low pressure. Now in between there, we're going to have strong winds. So as the high and low pressure systems follow each other around, it creates that wind that you feel on the surface of the earth.
Wind is the horizontal movement of air over Earth's surface. It is one of the basic elements of weather. The movement of air has more global effects too. The rising warm air, along with the sinking cool air, creates what is known as convection currents.
Okay, so here's another answer to your essential questions. It says blank warm air, so you're going to put rising, rising warm air and sinking, and actually we're going to put rising light or lighter warm air and sinking denser cool air causes convection currents. Okay, now for your picture, you can put the earth, warm air rises, cool air sinks. Warm and cold, warm air rises, cold air sinks. Okay, so that warm air rising and that cold air sinking creates these pockets of convection currents. And that's where we also get our global wind belts from, which is what we'll go over tomorrow.
Convection currents can bring turbulent weather as well as soft sea or land breezes. Temperature, air pressure, and movement of air by convection currents are closely related. They work together to circulate heat throughout the troposphere and produce many of Earth's varied weather patterns.
Okay, so after watching that, I want you to go ahead and try to answer this question on your own. What type of heat transfer is responsible for the movement of weather patterns around the globe? Okay, you should have written down convection. Convection is responsible for the movement of weather patterns around the globe. In most of our classes, we say warm air rises, cold air sinks, convection is really neat. Okay? You can go ahead and add that to your page. If you have crayons or markers at home or colored pencils, you can add the color to your questions as well. Warm air rises, cold air sinks, convection is really neat. I hope that you remembered a little bit through this video and it kind of jogged your memory of some stuff that we talked about right before we left. Tune in tomorrow to talk about global wind patterns. Bye.